would like to present our 4 presentation and our 4 topic. New features on the cybersecurity solution Raspberry Monitor to secure your VMS IoT application. I present you from Vanderbilt and Comnet, Mr. Fraser Johnston. After completing CCNA in 2005, he has been working in IT for more than 15 years of experience in IT, fulfilling various infrastructure and engineering roles. The last 5 years have been with Raspberry Technologies, starting in Dallas office performing infrastructure testing and Q&A, later supporting Raspberry from UK with sales engineering, and technical network specialist at Vanderbilt and Comnet, Mr. Fraser Johnston. Mr. Fraser, the floor is yours.
Hi, thanks very much. I was getting ready to do my own introduction, but you've got it very well covered. Thank you. So I've got half an hour here to talk to you all about Raspberry, which is about an hour too short. So I'm going to only cover some very high-level features and functions, as well as some new features that have just been released by Raspberry. So the presentation I've got today is just going to focus on some of those features and benefits that Raspberry Solutions provide. And we'll address and have a quick look at how those features provide benefits to both users, end users, installers, maintainers, managed service providers, etc. So Raspberry Solutions are formed from several primary ingredients, the first being intelligent video appliances, and that's our hardware component. And this comprises of servers, storage, and Ethernet switches. Some of our devices have all 3 of those. Some of our devices are just the server and storage component. And in those flavors, we have Server Switch IQ, the integrated device that has 8-port, 24-port offerings, as well as a brand new 32-port offering. And there is also a rugged device, which is this one here. So all of these devices contain automated cybersecurity software, which we've called Appliance Defense and Camera Defense. And they also have some very simplified and very easy to use, powerful system health monitoring software. So with the Raspberry Solutions, we can store video images, we can host video management and other system service types on our devices. So that could be door access, it could be time and attendance. We secure the servers and connect devices or IoT devices to a network. We primarily focus on camera devices, but again, this also lends itself to door access and time and attendance and other IoT systems that you can imagine. And importantly, we monitor our servers and the connected devices that are in the network and secure them. So the table that I've got here shows the different Raspberry product groups. The hardware, we have some core servers, which are designed on Dell chassis. We have the SSIQ, which is Raspberry, as well as rugged, and EPD, which is Endpoint Defender. The Server Switch IQ and rugged are our integrated devices, which contain the switch, server, and storage. And that means it's compatible with Appliance Defense, Camera Defense, as well as Monitor. Our core server offerings are Appliance Defense and Monitor. And our Endpoint Defender is a standalone switch that doesn't contain the server components, so it doesn't need Appliance Defense, but it still contains our Camera Defense, and we can still monitor that switch solution. So depending on the hardware type, Raspberry software packages are either embedded with Appliance Defense and Camera Defense, or they're overlaid Raspberry Monitor to provide our unique solutions. The server and storage, transmission, cybersecurity, and monitor all come together in the Raspberry offering. The sweet spot is the overlap of the 4 different technologies. So we're bringing these 4 technologies together, and right in the middle, we've got a sweet spot where we can provide all these functions. Now, other parts of these functions, that they're all designed with wizards to make simple configuration and guide you through for a quick setup. So we offer a lot of efficiencies in our software. And I can't really take you through that today because I've only got the half an hour. Right, so appliance defense, let's have a look at that. So the appliance defense is the first component that it resides within our server section of hardware. So anything that has a server has the appliance defense methodology applied to it. And it provides a number of industry best practices and cybersecure features and further additional features unique to Raspberry. Appliance Defense provides a cybersecure environment for operation with minimal input from the installer required. So we have these standard operating system features here. We're using Secure Boot. We have trusted platform modules. And we also have audit logs that are available both in Windows and within Raspberry Monitor. Now, the key difference in our server components that really bring appliance defense to life are the secure protocols that we're using, and also how we build our operating systems. Our operating systems are not just a Windows image, they're curated as part of using industry best practices to bring those operating systems into the physical security environment with many changes made. And what do I mean by those changes? So we look at security guidance people like NIST and other guidance areas to look at how an operating system should be pre-configured or configured as part of its intended use. Now that means that many Windows features and services are not required in the physical security environment, so we switch them off. And this is done from factory. And the reason we do this is so that your operating system used in a physical security environment has as many loopholes or potential attack vectors closed as possible. Now, this alone saves an installer a considerable amount of time per server to configure. Now, in many cases, this probably isn't done in a physical security environment. And in the IT world, this process of securing a server after it's been set up for a new desired function, whether it be an application server or a file storage server, could take a good engineer half an hour, maybe even an hour and a half to go through and make switch off all the features and functions that shouldn't be enabled as part of that server's function. The next component of appliance defense is our AI threat protection, and this is provided by a product called Cylance Protect. Now, Cylance was chosen to be packaged by our operating system as it's an AI-driven antivirus and anti-malware engine. Now, this means several things. One is that it does not need regular updates to keep it protected against new variants of viruses and threats. Which means it's effective against zero-day attacks. And this is because it's using an artificial engine that's inspecting absolutely everything that's being launched on your machine to give that that item that's launching or being read into memory a score against its artificial intelligence, and making sure that it's not something that's going to harm your system. The other side effect of this is that it doesn't require regular system scans, which is nice because regular system scans are usually quite processor intensive. And the second aspect of this is that in its normal every minute operation, it very rarely peaks over 1% CPU load. So it's very nice in a physical security system, especially CCTV, where we don't want our processor being heavily utilized by other systems. Camera defense is provided in all our Raspberry products, and this is the next component I'm going to talk about. And it's provided in all our Raspberry products which contain the Ethernet switch, that's Service Switch IQ, and it's the Endpoint Defender, as well as rugged device. Its purpose is to allow IoT devices to be connected simply and securely to our Raspberry environment, and in turn, your network extending beyond the Raspberry device. It's offering network security features that would normally only be available in layer 3 devices and above, and that would usually require IT experts such as CCNAs to configure. So the image that we're looking at here shows Camera Defense dashboard. It's located within the Ethernet switch, the graphical user interface for our switch. And the dashboard provides overview information on the configuration and posture of the individual features. So let's have a look at some of these features. The first one that we've got is device binding. And on the Raspberry switch, it's much more than just the MAC locking that you would see on standard layer 2 switches. Yes, both features tie the MAC address of the connected device to the switch port, but that's where our similarities end to the way that MAC locking or device binding is achieved on most switches. The fundamental difference is the fact that Raspberry build and maintain knowledge of the connected devices. At an IP level, we look at understanding the traffic type that is being generated. And any logical port that it may want to communicate on. If we use the analogy of a vehicle on the highway, a layer 2 Ethernet switch would see the vehicles, and in certain cases, it would tell you if it was a car or a truck. With Raspberry, we know the vehicle type, the paint color, the number of the wheels, the weight, etc. We gather this information through deep packet inspection, or DPI. Think of that as reading the contents of a letter that is inside the envelope, rather than just reading the address on the outside of the envelope. If an Ethernet port is not being used, we automatically shut it down, not relying on an operator to do so. This is all part of a wizard that we have to configure Camera Defense. Our power over Ethernet levels are monitored as well, but we also advise on those levels changing, which could be caused by a rogue attachment to a port trying to spoof a MAC address. So power over Ethernet usage, type, class, are all used in monitoring spoofing detection. And we use all these features together, combined, to not only bind the devices and stop other attack vectors, but we're also using them to maintain the system. And we also have a firewall in our layer 2 Ethernet switch, which is unusual, but it resides in every Raspberry switching device. As we previously stated, we have knowledge of the connected devices and want to know the traffic types and logical port, for example, the vehicle make and color. The firewall will limit data flow based on the traffic type and the associated port number. With a focus on CCTV generated video traffic, a single checkbox selection sets the firewall up for video traffic. Of course, other common traffic types can be selected through a drop-down menu, or custom port numbers and ranges can also be specified. Whitelisting is also a feature in Camera Defense, and it's looking at the source and destination IP addresses, and it blocks traffic. So both inbound and outbound, based on the captured address, in whitelisting, individual IP addresses or address ranges can be defined. We also have a simple checkbox for something that we call internet protection, and this is a setting that blocks all routable IP addresses. So this simple operation would block CCTV devices, let's say, trying to connect back to their home or mothership or head office. So it would also stop would-be attackers penetrating the network and using our devices or our cameras or IoT devices for any DDoS-style operations, or using them as individual processors to hack other environments, because it's simply going to stop that traffic getting from its source to wherever it's trying to get to, and only allow it to connect to the networks that you want it to connect to, which in most cases is simply the CCTV server component. One of the last features of Camera Defense is password protection, and we're using deep packet inspection here and the knowledge of our connected devices, and we're assessing the security level of the passwords that are provided for our endpoint devices. So, and we do this as when cameras authenticate, if they're not set up for HTTPS, which is quite common, we can see the authentication password being passed to the camera. Now, using industry listings, especially from NIST, Raspberry devices hold a list of approximately 10,000 most common passwords. By interrogating those plain text passwords that we see when cameras are authenticated, we can advise if it is at a level deemed to be secure or not. In addition to the standard list, system unique passwords can be added to provide further security to the system. For example, old admin passwords no longer considered to be secure, they could be added to this unique passwords list as defined by users. Camera health is the next feature that sits on our server, and it's looking at camera, so it will capture all the information of video and audio streams. If video or audio streams are lost, we can do automatic reboots with power over Ethernet to those devices, so that we can attempt to recover the stream. If a stream cannot be recovered, alerts can be triggered to dispatch maintenance teams to either replace a faulty camera and/or check the cabling. Camera health sits outside of camera defense, but it should be viewed as another integral part of camera defense. It has its own tab in our user interface, but it really is part of the camera defense suite. It captures all the video information. So monitor is the next part that ties our physical servers and our software and our cybersecurity features together. And monitor is an agent that sits on all of our devices, and it can be used on third party as well. And it captures information from our hardware, and it presents that data in a clear format for users, operators, managed service integrators, etc. And it provides clear dashboards and creates reports configured to your requirements. Any hardware device having the monitor agent installed can be viewed within the monitor platform. Information is communicated with other management platforms as well, such as SolarWinds. We can integrate directly with Milestone. We can integrate with syslog servers as well, which opens up lots of opportunities for other Splunk systems that you might already use. Currently, it's operating as a cloud-based system, but we have an on-premise solution that is being developed and is being released at the end of this month, so that you can take your monitoring environment into your core networks and not have to use the cloud-based solution. So in the interest of time, I cannot go into the full details of monitor, but I wanted to just take a moment to show you the types of items we are monitoring and alerting. The cybersecurity and IoT alerts are based on camera defense and appliance defense. So we've got offline and offline module statuses as well for the various parts of our system, be it a switch, an internal switch, or even the server itself. We also have the VMS health. This is all related to Milestone integrations, and our IoT solutions here as well. So if we lose audio or we lose video, our cameras are maybe in a state of disrepair or have a firmware issue, and they're going through excessive reconnects. And then we're also alerting on an automated power over Ethernet reboot if we lose audio or video. Now the server set here is a very useful set of alerts that focus on the Razberi connected server as well as third-party connected servers. The alerts have a top-level description, but we'll look in more detail during operation. For example, the disk health alert will utilize the smart data function on all hard drives, whether they're high-density disks or they're solid-state disks, and will advise on any potential issues. The smart data analysis is a number of a threshold of parameters and provides proactive maintenance information on all storage drives within the device. For example, a sector error threshold breach would be indicative of a hard drive which may fail soon, or is already storing corrupt video data and should be replaced ASAP. So alert data is presented clearly through monitor, and the alert data is shown by device, the location, the alert type, and the description of that alert. Monitor will capture all alerts from all connected devices. And you can see here the type of alerts that we're getting, like there's a Windows event alert here, and it's telling you, that the kernel power had shut down. And it tells us exactly which machine this is, and we can click on the machine in the alert log and get more information on that machine so that we can remotely connect to it or send an engineer to power cycle it. Similarly, with our other alerts here, let's have a look at this brute force attack. And we can see that there's a brute force attack and it's been detected, and it's targeting this MAC address, and its IP address is this, and it's on switch port 1 of this particular server switch IQ rugged machine. So we get a lot of very direct information that leads us straight to the problem without having to do any guesswork to figure out which devices are causing the issue. We know that. We know it's on switch port 1, and we know it has this IP address. So all our captured alerts can be communicated to the outside world by setting up alert profiles. The profiles are custom created, and we're based on a number of things. A combination of one or up to all of the individual alert types. Locations of the units based on information provided at the time of adding to monitor. Or tags. Tags are filters, and they can set up and add more selection options to the profile. For example, we could define a tag called security that would only send CCTV issues to the security team, and then a tag called IT that would send all of the server and cyber issues to the IT team. Further examples could differentiate perhaps service level agreement times based on the critical nature of the device. Alerts are then sent by email or SMS, so it's a very powerful and easy to configure process. Now, in addition to all those alerts and items that are monitored, Raspberry Monitor has just released some new features. This is brand new, and it was released at the end of February. On the list, I'm only going to pick on 2 of these subjects, and that's Windows updates and custom scripts. But we now have some manage functions that are built into Raspberry Monitor where we can gather server logs. We can install Silence if it's missing from a particular machine. We can remotely reboot the devices. We can send custom scripts. We can apply particular Windows update files. And we can also restart Windows services and run the full Microsoft update process. So it seems quite typical in CCTV servers we've looked at that often Windows updates are switched off simply because you don't want Windows putting itself offline during a busy period or crucial times. This can create an administrative nightmare for operators to schedule the manual process of updating all the Windows machines. The more servers there are, the longer it can take. Now with Raspberry Monitor, we now have the ability to schedule all our monitored machines to push a Windows update cycle when we choose, and importantly, whether or not we want Windows to restart after applying these updates. And this means we can schedule a separate restart for a time when we have engineers that are available to respond to Windows machines that do not come back online after a Windows update. And we'll know whether they come back online or not using Raspberry Monitor anyway. So very quickly we can figure out where the problem machines are after a full Windows update cycle. And the second most powerful feature here is the ability to remotely deploy custom scripts. Now the custom scripts, this means that using PowerShell scripts, we can deploy to any of our machines that are monitored by Raspberry Monitor. And this opens up a world of remote administration to having no limits whatsoever. There's an awful lot of things you can do with custom PowerShell scripts. Now, both of these features, I think, are amazing, as you don't need to be connected to the local network of the servers in questions, nor do you need to have any dedicated management servers to handle typical system engineering tasks, such as a WSOS or a group policy admin server, to name a couple of features that are required to do these sorts of things. So what does all this mean for end users? I'm really going to be quick with this, but these benefits are really for end users as well as they apply to any stakeholder, be it a managed service provider or an owner or whatever, really. But we're providing system availability. We keep the system working and performing securely to the specifications they were originally purchased. This high system availability is the combined positive effect of the features that I have just touched on. Those features drive the following benefits. Configuration. Everything is easy. We have lots of installation wizards. We guide you through and ensure it's set up correctly, quickly, and securely. Camera defense only takes 30 seconds to switch on if you just follow the wizard. Information, we get dynamic operational details on system health, security, and status. And when something goes wrong, exactly what is going wrong. Efficiency. Through enabling designs and operation that minimize network traffic, we have a switch directly on our server. Our cameras are going straight to the server. They're not having to transmit over any other existing infrastructure. So we're able to reduce discrete devices in a network and get the best from the system that we have. I've not touched on exactly how we go about this today, but I can follow up with anyone who is interested later. Cybersecurity, providing security for the products and the system through its lifetime. Improved service cycle, using the full Razberi platform with all the cybersecurity features combined with a monitoring package. End users and system integrators can drive better maintenance programs and more efficient ones. Wouldn't it be better to go to the site knowing a particular camera isn't working? You can go armed with that exact camera model as a replacement. You even know its IP address. You can pre-IP address it before you go to site. And visit once rather than multiple times. Wouldn't it be great to know that the hard drives are not operating or they're about to fail? Arrange a replacement hard drive with us and go to site once to make the replacement happen. Both of these are examples where you, as a service provider, can go to the customer with the solution rather than waiting on the customer calling some days, weeks, or even months after a failure has occurred and the relevant video they need is not there. We can help you make sure your IoT devices are functioning properly and customers' systems are operating as intended. Thank you very much. We don't have very long left, so if there's any questions.
Mr. Fraser, thank you. Thank you for everything, for your inspiring presentation. As Vanderbilt and Comnet say, begin, believe, become. We will begin, we will believe, and become. Thank you for your presentation. For now, we don't have any questions. In case we receive any questions, we will forward it to you. Thanks again.
Very good. Thank you very much.
We also encourage all our participants to schedule meetings through Connect2B platform.